Model steam engines, top tip time, part 36. Once again, this episode of Top Tip Time contains a great deal of information if you're into repairing or building miniature steam engines. Why do I make this series? It is obvious that all the clips are from previous videos, but the number of times I get asked questions that are covered in the videos, and viewers haven't bothered to watch the video all the way to the end. That is why I decided to make a special series which features a wealth of readily accessible techniques for repairing and rebuilding steam engines. If you don't want to watch the full series to the end, I definitely recommend watching these clips to the end. There's a lot of information here. To start off this episode, I would like to show just how critical valve timing is. I disconnected the valve linkages and rotated the valve spindle one turn, and as you can see, there's quite a difference. With not much air pressure, the engine runs very unevenly. Then it makes a sound like a pneumatic drill when it runs fast. As I mentioned previously in quite a lot of videos, early admission of the compressed air or steam is very desirable to cushion the parts. If the valve timing is late, that's one of the reasons why you get a knocking sound. This clip clearly demonstrates what happens if you advance the timing too much. The flywheel just oscillates back and forth, it doesn't really rotate. It's good to experiment with valve timing. I do this a lot just to see how good I can get engines to run. Even this one, which is in very bad mechanical condition, will run with a lot less noise if I get the valve timing precisely in the right position to suit the mechanical condition of the engine. This of course is still far too advanced. By slackening the Allen head grub screw, I can move the eccentric sheave to a different position. Once again, this is what happens if the eccentric sheave is in the wrong position. I'll try again. You can see that I'm not moving the eccentric sheave very much, but it still makes quite a difference to the way the engine runs. This is a health and safety warning, you must not do this. I have my hand on the connecting rod, and I'm just checking that none of the knocking is coming from this area. When I was holding the connecting rod, the engine made a lot more noise, but that was because of the resistance I was putting on the engine. This is a really dangerous thing to do. If you get your fingers in one of these steam engines, they really do bite. The first proper steam engine that I built was a Stuart Victoria, and prior to that I'd only ever played with small Mammoth steam toys. When I was setting up the Victoria, I was really shocked when the crosshead suddenly shot forward and trapped my finger, causing bleeding and considerable pain. I didn't do it again. And these days, as I work with steam engines and machine tools, I have a great respect for them. Some of the things that I do in the videos are for the benefit of beginners, so keep your hands well clear of the machines at all times. And here I'm doing it again. This is a very bad place to put my hand. I should really use a piece of wood, or a screwdriver like I'm showing in this clip. I'm applying some pressure with the screwdriver to the piston rod, pressing it down to see if the engine runs any quieter. At this stage I'd got the valve timing to quite a good position that was very sympathetic to the wear and tear of the engine. Another very slight tweak should do it. Here's an example of what can be achieved by obsessively tweaking the valve timing on a worn engine. A few clips back I was oiling the engine, and I was oiling it with steam oil, which is very thick and sticky. But the thick, sticky steam oil fills the gaps in the worn bearings, therefore cushioning the knock so it's not as noisy. This is not a fix, it's just a bodge. Disconnecting the Watts parallel motion from the beam and the fitting on the piston rod. Only then will I be able to see how bad the wear really is. I've got a good idea what the workmanship's like, I can see that clearly. There are two things I need to look at, and all of them involve clearances. The block on the end of the piston rod has been bushed with phosphor bronze. The bush is supposed to be 3/16 of an inch in diameter, but it's much bigger than that, and it's not in straight. Here I'm checking for wear on the pins, and comparing it with a drill shank. This is not an ideal way to do it. The drill shank is also slightly undersized by about half a thou. A much better way to do it is to buy some 3/16 of an inch diameter silver steel which is accurately ground and use the micrometer on that. and then make the pins from it. Depending on how worn the Watts parallel motion linkages are, I may have to make an oversized pin. I don't know yet, I'll find out in due course. Have a close look at this top cylinder cover. What's wrong with it? The top surface hasn't been machined, so it's at a bit of an angle. Have a look at the bolt that holds the cylinder cover in place. This is no good at all, and in due course I will machine the top of the cylinder cover flat. For now though, it's time to remove it. The bolts have gone, and I'm using a very blunt chisel just to tap the cover off. Once I'd done that, I could have a look at the piston, which was actually loose on the shaft. It's made in two halves to take a piston ring, but unfortunately this piston ring is the wrong size, and it has a piece of wire around the inside to push it out a bit more. I didn't expect this, and I'm quite surprised why anyone would want to do a job in such a bad way. This piston is not a good fit in the cylinder, and explains why I could always hear a slight blowing when the engine was running. To make it worse, this piston ring didn't fit all the way around. There was a big gap in the ring. I intend to make a new piston and fit a silicone O-ring. That way it will seal and it will be better. This phosphor bronze bush is rubbish. I'm going to replace it with a new one. And the good thing is, as soon as I applied a drill to it to drill it out, the entire bush came out of its housing. So that was an easy job. With the piston removed, you can clearly hear when the air is admitted to the cylinder, and this needs to coincide with the crank web being just before top dead centre at both ends of the stroke. And as you can see here, the timing is quite late. For the final part of this episode, I'm going to use some gun wash, which is cellulose thinners or lacquer thinner for cleaning spray guns, and I've poured some into an aerosol can cap. All I need to do now is put the top cylinder cover in this stuff to remove the paint. And that's it for this one. Stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.